Go.
Hello everyone, I'm Dhruv Paul, and today I'll be giving you my paper slide presentation of the atmosphere layers. I would just like to put a disclaimer out that not all the pictures are very good, as I drew them, meaning they're always going to be very bad. Like, you see this Earth, it's not even circular. So, that's the only disclaimer. And let's start. The first layer is the troposphere. The troposphere is the first layer of the atmosphere, and it is the closest to the Earth. Almost all weather is created there, and it consists of mostly hydrogen and helium. It comes from the Greek word of tropos. It has an altitude of about 4 to 12 miles. The density is approximately 33.6% of sea level density. Sea level. According to NASA, it can be solved by this equation right here. This is the equation that NASA scientists use to solve for density. And the pressure can also be solved by another NASA equation right here. And based on the website of Glencoe, the pressure can range from 101,300 to 26,499 in Pascal. The temperature of the troposphere can be limited from negative 15 Celsius to negative 53 degrees Celsius. And some things that can be found in the troposphere are clouds, snow, descending and ascending airplanes. And here is our picture here. No. And our next one is the stratosphere. The stratosphere is the second closest atmospheric layer, just behind the troposphere. The air is more dry and less dense. Some of the highest clouds in airplanes are found here. The word originates from Latin stratus and French sphere, stratosphere. Here are the stats. The temperature can range from negative 53 degrees Celsius to negative 2 degrees Celsius, according to the Glencoe website. Pressure in the stratosphere can measure as 1 millibar or 2,599 to 90 Pascal. The altitude is recognized to be in the range of 12 to 31 miles. Based on the Glencoe website, the density is estimated to be 3.2% of sea level density. And things that can be found are some of the highest clouds and most airplanes. And now we have the mesosphere. It lies just above the stratosphere, 30 to 50 miles above sea level. Contains chemicals that absorb energy from the sun, and the word originates from Greek. The altitude ranges from 31 to 53 miles as the temperature decreases with the height and can have negative 90 Celsius average temperature. Pressure decreases rapidly from 90 Pascal to 2.7 Pascal. The density also decreases from 0.9% of sea level density to 0.044 approximately. Some asteroids and meteors can be found there, but most of them burn up fairly quickly there. And the chemicals from the sun, such as ultraviolet rays. And now the thermosphere. It is a region of the upper atmosphere in which temperature increases continuously with altitude, encompassing essentially all of the atmosphere above the mesosphere. It is from and originated from Greek. Its statistics have altitude ranging from 56 to about 311 to 621 miles. We couldn't find an exact estimation. The temperature ranges between 500 degrees Celsius and 2,000 degrees Celsius according to UCAR. The density is approximately 910 kilometers to 410 kilometers. The pressure is an estimated 100 kilopascals. Here's our picture again. And what can be found in it? Earth satellites, atomic oxygen, X-ray, and UV radiation, and a little bit of helium and nitrogen. Then we have the ionosphere. It is the layer of the Earth's atmosphere that contains a high concentration of ions and electrons and is able to reflect radio waves. Lies above the mesosphere, and the origin comes from Scottish radar pioneer Robert A. Watson. He lived from 1892 to 1973. The temperature varies from -99 Fahrenheit to 440 Fahrenheit. Altitude stretches from 30 miles to 600 miles. The pressure in Pascal ranges from 2,699 to 0.0000098. As the density of the ionosphere is electrically charged, its maximum density is 106 kilometers per centimeter, 106 electrons per cubic centimeter at 250 kilometers. This number severely drops to 1 electron per cubic kilometer. Just 1. And what can be found? Some optical and radio emissions, radio waves, and incoherent scatter radars. And here's our picture again. And the final layer of this presentation is the exosphere. The definition is, it literally means outer sphere of change. The exa comes from it being the furthest layer, as sphere of change comes from French. Stats. The temperature ranges from 0 to 1700 Celsius. In kilometers, the height ranges from 500 and 190,000 kilometers. The pressure in the exosphere is essentially 0 degrees. The pressure is not 0 degrees, but it is 0. Although there isn't a direct answer, from many articles I can claim the density to be a severely small fraction. And what can be found? Helium, hydrogen, and possible satellites. Here's our picture. And that's the end of the presentation. I hope you enjoyed it. Here's some of the sources that I have made. I cited them in MLA format. So, yeah. I hope you enjoy, and I will see you later.